In this video, we're going to talk about factoring trinomials by grouping. So recall, factor this polynomial. So I want to find factors of 10, which is a constant, who add up to be 7. Well, 2 times 5 is 10, and 2 plus 5 is 7. So I can factor as x plus 2 times x plus 5. When you have trinomials that have a leading coefficient that is not 1, we must factor these trinomials differently. One approach is factoring these trinomials by grouping. This method is the FOIL method in reverse. So let's take a look at a couple of examples. So with 6x squared plus 13x plus 5, notice the coefficients of the outer and inner terms are 10 and 3. Also note that 10 times 3 is 30, and 10 plus 3 is 13. And also note that a times c, which is 6 times 5, is equal to 30. In the middle example, notice the coefficients of the outer and inner terms are negative 6 and negative 5. Negative 6 times a negative 5 is a positive 30. And negative 6 plus a negative 5 is negative 11. Now, what do you notice here? Well, we're trying to find what? Factors of a times c whose sum is b. Okay, so then let's take a look at a couple of these then. So I want to be able to factor completely. So the first thing I want to do, is there a greatest common factor I can take out of all the terms other than 1? In this case, no. So I want to find factors of 2 times 12, which is 24, whose sum is 11. Okay? So in this case, we know 8 times 3 is 24, and 8 plus 3 is 11. So what am I going to do? I'll rewrite 2w squared, but I will now put plus 8w plus 3w. That will replace the 11w because 8w plus 3w is 11w, and then plus 12. Well, now notice I have 4 terms, so now I can do factor by grouping for the rest of this problem. I can factor out a 2w from the first 2 terms, and I'm left with w plus 4. I can factor out a positive 3 from the last 2 terms, and I'm left with w plus 4. Notice now, with the big factors, I can factor out or divide out a w plus 4, and what I'm left with is a 2w plus 3. So on the side here, I'm going to multiply to check my answer. In this case, we get back to the original equation, and we're done here. Okay, let's take a look at the next example then. So first off, is there a greatest common factor I can take out of all the terms other than 1? In this case, that's no. The leading coefficient is not 1. So I want to find factors of 21 times 2. Well, that is 42, whose sum is a negative 13. Okay? So I know that negative 7 times a negative 6 is a positive 42, and negative 7 plus a negative 6 is a negative 13. All right, so I'm going to rewrite this as 21x squared minus 7x minus 6x. Negative 7x minus 6x is a negative 13x plus 2. So again, I'm going to do factor by grouping again. So I'll group these 2 terms and these 2 terms. From the first 2 terms, I can factor out a 7x. That leaves me with 3x minus 1. Remember, negative 7x divided by a positive 7x is negative 1. Notice here, the first term in the second set of terms is negative, so I'm going to pull out a negative. I can also pull out a 2. So negative 6x divided by negative 2 is a positive 3x. 2 divided by negative 2 is a negative 1. Both of these larger terms now have a factor of 3x minus 1. When I divide that out, I'm left with 7x minus 2. So on the side, I'm going to check by multiplying to make sure I have the correct answer. So you can see when I multiply the 2 factors, I get back to the original trinomial. Okay, let's take a look at the next example then. So the first thing, is there a greatest common factor I can take out of all of the terms other than 1? In this case, I can factor out or divide out an x. So now let's go inside the parentheses. Again, the leading coefficient is not 1 with 3 terms. So I need to find factors of negative 84 whose sum is negative 8. So in this case, this will be negative 14 and a positive 6. Negative 14 times 6 is negative 84. But when I take negative 14 plus 6, that's negative 8. Okay, so let's rewrite just the trinomial below. So I'll put in minus 14x plus 6x minus 21. Now, I could put the plus 6x and the minus 14x in the opposite positions, and you still would get the same answer. All right, so let's do factor by grouping. So I can factor out a 2x from the first two terms. That leaves me with 2x minus 7. I can factor out a 3 from the last two terms. That's 2x minus 7. So I can factor out a 2x minus 7. The other factor is 2x plus 3. Do not forget the greatest common factor that you've already factored out, which is x. And I've completely factored here. So let's multiply to check our answer on the side to make sure we get the original problem. And in this case, we do. Okay, one other example I want to take a look at then. Is there a greatest common factor I can take out of all of the terms other than 1? The answer to that is yes, that's a 2. So when I divide out a 2, I have this. Now, we still have 3 terms where the leading coefficient is still not 1. So I need to find what? Factors of negative 150 whose sum is a positive 19. So in this case, that's going to be 25 and negative 6. 25 times negative 6 is negative 150. But when I add the two numbers together, I get a positive 19. Okay, so let's rewrite then. And I'm going to use plus 25a, and I'll do minus 6a minus 10. All right, so I'm going to factor by grouping. From the first two terms, I can factor out or divide out of 5a. That leaves me with 3a plus 5. Here, the last two terms are both negative, so I'm going to take a negative, but I can also factor out a 2. That leaves me with 3a plus 5. So then from here, I can factor out a 3a plus 5 from each, and the other factor is 5a minus 2. Again, do not forget the greatest common factor that you've taken out earlier, which is a 2. And we're done here.